CBS 6 meteorologist Sam Coplin here with a very special guest today on a topic that I personally am very excited about. It's CEO Alex Levy talking about his company Atmo, which is using AI to sort of harness the accuracy, to increase the accuracy of weather forecasting. So thanks so much for being here.
Yeah, happy to be here and talk about AI for the atmosphere.
Yeah, so we talk so much on the news, practically every newscast. There's one story after another about AI, and a lot of them tend to be very doomsday in nature. So what exactly is Atmo? And just to be clear, it's not the end of the world, right?
Well, it is quite true that, AI is a field that's been moving really fast. To see what's happened in AI and language and images and videos just over the last, 1 to 2 years has been breathtaking, even for people in the field. And of course, people are looking for applications that are socially beneficial, that improve the lives of everyday people. And applying AI to the weather is right up there at the top. So one of the great pieces of news has been that these great technologies, which are great at predicting, let's say, the next word or phrase or sentence of text, very advanced versions of those can be used to actually predict the next hour or day or week of what the atmosphere is going to do. And so this big globe that you see behind me is a world weather model that, unlike others that have come before it, is generated with AI, and it is more detailed, more accurate, and runs faster. And the upside of this is forecasts around the world are about to get a lot better with AI.
What exactly was the inspiration for this idea, this concept?
Well, of the top issues in the world today, AI and climate change and extreme weather have got to be maybe two of the top five. So it's really natural to start thinking about how can we use the most advanced technology in the world to help try to address one of the biggest problems in the world. One of the really effective ways that you can respond when you're going to experience more extreme weather in your life and in our daily lives is to improve the quality of predictions. And so it was very tempting for us to try to apply this technology to this really big problem. And the other reason is my co-founders and I here at Atmo had this background in AI for physics, using AI to make predictions about the physical world. So we had built businesses using AI in the pharmaceutical industry to design new medicines, or AI in cardiology to diagnose heart disease, or AI in space to design satellite thrusters. And so we said, we've got these great tools, and the biggest, baddest simulation of all is the simulation of the atmosphere. And so that's when we decided we're going to look into, can we bring AI to atmospheric science? And that's what we've done over the last 3 years.
And it's definitely, seemingly more relevant than ever with climate change, and it seems almost an unprecedented amount of, climate disasters taking place year in and year out.
Yeah.
And, the contemporary way that meteorologists use to forecast, like me, is using computer models like the European, the GFS. But from what I understand, Atmo isn't you. So computer models basically are taking current observations and simulating how the atmosphere will play out in the future. But Atmo starts with those same observations, but then thereafter it's different,
Yeah.
right?
Yeah, that's right. I think the way to think about the difference is the difference between learning from the textbook versus learning from experience. So the classic models that are out there were built in a very logical way for their time in the 60s and 70s and 80s, which is we're going to write down all of the equations of the atmosphere. We're going to take our best picture of how it is today, and we're going to take the math and we're going to propagate it forward, how the pressures must move, the energy must move according to these rules. But one of the problems is that old way of doing things didn't have a learning process associated with it. So let's say errors or biases crept in there that meant you missed a major event. Like let's say you miss that Hurricane Sandy is going to go for New York, let's say. The problem with the old way of doing it is it's not a machine learning system. So if it makes that mistake, unless you correct it by hand, it's going to make that same mistake again the same way next time. By contrast, the AI approach to simulation for the weather is you're going to show the system vast quantities of historical data up to the present minute, and you're going to rigorously test it. You're going to make it make millions of forecasts. It's going to make lots of mistakes. And every time you're going to issue millions of corrections. And in the accumulation of those millions of corrections and experiences, you extract an AI model actually that's far better at predicting the atmosphere than the rule-based system can do alone, and that can spot its own mistakes and fix them dynamically. And as a result, the new AI weather forecasts that we provide to countries and militaries and corporations are the most accurate that we've seen, and also significantly more detailed. And also, amazingly, the math runs faster. So we can produce what would have been a 6-hour global forecast, we can produce in approximately 8 to 10 seconds. So It's a really new way of approaching the problem, but it appears to be a real leap forward for meteorology.
Hmm. And for people that don't know, that most models, they're generated on these supercomputers that are very expensive and they take hours and hours to produce new simulations. But Atmo, as you said, is a lot quicker.
Yeah, that's exactly right. I think a lot of people don't think about how a forecast gets made. We receive forecasts, but you maybe don't stop to think, well, where is it coming from and who's making it? But it turns out that of the top 100 supercomputers in the world, we estimate that about 50% of them are used part-time or full-time to predict the weather and climate. So this is one of the biggest application of all humanities computers is to predict the weather. Really, really big. But the dark side of that is if you need $1 billion or $10 billion worth of computing in order to produce a weather forecast, it limits the people who can do that to a very elite club. So you might have the European model, you have the American model, maybe you have the Japanese model and a few others. But actually, there's a world of countries and corporations and militaries and everyday people that would like to create improved, better forecasts for their own purposes. So one of the advantages of this new AI meteorology approach is we can let 1,000 flowers bloom. We can make 1,000 forecasting models and to customize them to the particular needs of particular people. So, let's say you're a tropical Southeast Asian country, temperature forecasting may not be that big a deal to you because it's kind of warm to hot, but rain might be a really big deal to you. So you can say, I'm going to make a forecast under my control that's optimized for rain. Or let's say you're in a place where wind is the big issue. Cape Canaveral for rocket launches, their primary concern is, are the winds too high or low? You can focus on that. And so what we're going to see is a decentralization, a democratization of weather forecasting using the new AI method because it doesn't cost $1 billion to get started.
Wow. I mean, cool. I think we're all excited to see it. Would we be able to see sort of a rudimentary?
Yeah, let's get into it. I would be very happy to show you one. Okay, so I'm going to show you Atmo San Francisco. So, Atmo is a San Francisco-based company. I'm joining you right now from an area of San Francisco, Soma, or south of Market. And I'm going to show you the most detailed weather forecast in America currently. Okay, so welcome to this. This is Atmo San Francisco. This is just running in our web browser, and it's showing a visualization of what the machine is predicting with these big neural networks. So first of all, this is a full 3D representation of the Bay Area with super accurate terrain and composition. So you can see the difference between the bay and the land. You can see all of the hills and valleys. And I'm showing wind right now. So light colors are high winds, dark colors and no colors are low wind. And one of the amazing things that you can see in Atmo are microclimates or even nanoclimates that you couldn't see before. And this is a true forecast. This isn't looking at the radar. This is really making a prediction days into the future here. And so we can see, for example, this is a really wonderful example, which is look at this Venturi effect, this sort of cone. So we've got the Pacific Ocean here at the bottom of the screen. We're now heading east into the bay, and you can see the wind gets funneled between these two peninsulas and then gets expanded out the back with these very high-speed winds.
And this goes down to street level.
Absolutely. We're forecasting here essentially city block by city block. This is about 1,000 feet by 1,000 feet by 5 to 10 minute increments. So it's roughly 100 times more detailed than the previous forecasts available here. So which means I can go down to our neighborhood here, Soma, and you can see that the winds are actually going to be very low, 6 miles an hour. And if I go half a mile to the north, we're at 17, probably gusts of maybe 30% higher than that. And so that ability to go block by block or hill and valley by hill and valley is why Atmo has been very rapidly adopted by the most elite users of meteorology, particularly folks in the military and high impact situations and public safety, because they want to know this level of detail for their planning and response.
And the San Francisco area is it reminds me a lot of the Albany area because you could just go over a 20 or 30 mile distance and you could have a completely different microclimate. The winds could be funneled through the valleys. You could have snow and higher winds over like the Berkshires, and it could be raining and having much calmer winds through the valleys. So I could see how this could be super applicable for a lot of small localities that have big differences over just a small range.
Absolutely. In fact, we're really excited to bring Atmo to New York. We're actively exploring the best way to do that. Obviously, we brought this to different places in the US and certainly foreign countries, and we'd love to do it for a place like Albany. So look out for an albany.atmo.ai potentially in your future.
As long as it doesn't take away my job, that's fine.
I think it makes your job better. And the reason it does is because if you're working from this and some other meteorologist is working from the blurry one that can't show all this, who are they going to listen to? They're going to listen to you.
Yeah. And I think it's worth noting that so there are some models that go very high resolution, which means shows a lot of great detail, but they only go out, up to maybe 48 to 72 hours. This seems like it goes out much further out in time.
That's exactly right. So Atmo makes full medium range forecasts. So depending on where we do it, we go out to 10, sometimes as much as 14 days, depending on the characteristic we're looking at. And we're able to maintain for longer, higher fidelity, higher accuracy further into the future than has been done before. So we go well beyond that 48 to 72 hour window onto much longer timescales.
And you also have a global model, correct?
We do. So, we've now been fortunate to do this at all different scales. We've done this at the scale of a city. We've done this at the scale of a country. And actually, we were the first to do it at the scale of an entire planet to put into production that. So let me show you here. At first glance, this is just, a kind of a normal weather model in the sense that it shows the whole planet. This is showing temperature in this case, as you can see. And we've got total global coverage. And in a sense, that's not that interesting. What's interesting is how this was made. Prior to Atmo, if you went back just a couple years, if you told somebody, I'm a global forecaster, they would assume that somewhere in the back of your building, you've got a $100 million supercomputer or something really big, because that's the kind of horsepower you needed to generate a truly global model every day in real time. This model runs more than 40,000 times faster than the prior numerical models. And that means I can make what would have taken a forecast, 4.5 hours to 6 hours on a big supercomputer. I'm making this on a relatively small computer in a span of 8 to 12 seconds. And so the idea that a small team of people at a startup in downtown San Francisco could be producing competitive world forecasting models that are as accurate or more accurate than any that have come before, that's truly new in meteorology. There's never been that kind of shift in the ability for people like us to do this. And this is an example of that.
Wow. And this is temperature. It looks like you also have wind and rain.
Absolutely.
And I could imagine rain could be something super relevant for like monsoon areas in the
Yes.
Indian Ocean.
Yes, absolutely. Yeah, we've got wind here. That's our wind color scheme again. So you can see a couple little storm systems here. We can go to rain. Let's see how that's looking.
So is it all initialized off current observations?
Yes, that's right. So, in a sense, we're all starting at the same starting line, which is the old way of forecasting and the new way of forecasting start in a way with the same initial clues. So on any given day, Atmo is taking in all the world's weather satellites, all the world's ground stations, all the world's radar stations, just like the big national forecasters or global forecasters do. But we're making faster, better sense of that data to translate it into a more accurate, more detailed forecast. So we start from the same beginning, but we get to a much different result in a much different way.
And you have some of this, how much more accurate? I don't know if you said it already, does this tend to be compared to some of the other computer models out there?
Now, accuracy depends on a lot of different things, where you are and what you're measuring. So be it rain or wind or temperature. However, AI weather models have demonstrated accuracy improvements on the order of 20, 30, even 40%, depending on the phenomena that you're looking at. And so that's a big gain. To put that in context for your audience, the classical models of numerical weather prediction, this kind of method that gets better by hand over time, they were only getting about 1 to 2% more accurate every year for the last 30 years. So the idea that in an 18-month period, you could make a forecast 30% more accurate, that's like the equivalent to all the progress that was made between 1990 and today, making that much progress again in like a year. And so that ability to increase, 20 or 30% may not sound like much, but to a meteorologist, it's big.
Yeah. And not to mention how much more it costs, that small percent gain for the computer models over a 30-year period.
Yes.
It costs so much money.
Yeah, you're quite right. Like the idea would be, okay, we're going to go out there and we're going to spend another $1 billion over a period of 5 years to get that next 1%. And the idea that startup, obviously we're not yet a $1 billion company, can go out there and with the level of resources that we have, can make bigger gains than that in a very short window. It's kind of wild. I mean, it's very akin to when startups go into space, for example, something that used to be the domain exclusively of the biggest governments with the biggest budgets, and now it's done by private companies. So too with meteorology.
So what's the long term? What do you foresee as like where will Atmo be in like 20 or 30 years?
Well, we think that this technology should get into the hands of as many people as possible around the world. So, our vision is to bring AI weather models to the majority of the world's countries, militaries, and big corporations. We're really focused on how do we roll this out as quickly as possible. So we have all these examples of different places we've worked, but I expect to double that and then triple that and eventually get coverage all over the world in really fine detail. And I think that would be a great benefit to probably a few billion people. So that's what we're going to try to do first.
Yeah, and we're very fortunate here in the US to have lots and lots of observational sites, high-tech models, but most of the world doesn't have these observations, don't have these high-level models. So I can imagine something like this could be super useful.
You're absolutely right that there are really big gaps in the level of forecasting around the world. A lot of people don't realize that different countries and different regions have different quality of forecasting for a variety of reasons. And the result is what might count as a really good forecast in a mid-latitude country or a tropical area or something like that might actually be to the low end of accuracy in the continental US or continental Europe. And so we have something of a duty and an opportunity to try to smooth out these inequities and bring gold standard forecasting, not just to the countries you might think, but really to all regions and locales around the world. And doing that is going to raise the economic productivity, the standard of living, and most importantly, I think the safety of many millions of people. So AI is going to bring forward forecasts for countries and regions like that are really going to change the shape of their daily lives for the better.
So there you go. It's not all doomsday AI.
Exactly.
Yeah.
Exactly.
And again, I already touched on this a little bit earlier. So a little bit of a selfish question, but I shouldn't view this as a foe. It's more of a friend to the broadcast community and just meteorologists in general.
I think it's a friend. The reason that it's a friend is what people look to you and your colleagues for is analysis, understanding, recommendations, and so forth to put into context this vast quantity of data. Atmo may produce these wonderfully detailed, wonderfully accurate forecasts with AI, but they are not self-explaining. They don't tell people what the key points to take away from are and how to put it into the terms of their everyday lives. And so I think in that sense, AI forecasting is just more raw material for really smart meteorologists like you to turn into the analysis that people want to hear.
Mm. Yeah, I mean, I just thinking about getting that type of detail in like the Albany area that we saw in San Francisco, how much easier, but how much, helpful that would be for the viewing community. I can't tell you how many times there'll be a snowstorm and I'll get a million messages saying that there's nothing here. There's so much in the mountains. Why are you talking about it?
Yeah, exactly. Imagine I'm guessing that in those cases, you have to do a lot of guessing. You're like, okay, I've got this big general picture. And from my experience, I've got to guess how that really translates to street level, really translates to block by block.
Yeah.
Guessing is good and you probably make great guesses, but you might also love to have a readout block by block that you can just pull up and look at. That would probably help you answer those questions.
Yeah. All right. Well, you got me hooked. You got me excited about this.
Yes, sir. I hope we can bring this to you and many others in your business.
Yeah, we definitely looking forward to it. And I'm sure, in 10 years, this will be above what we could even imagine currently. Yeah.
Thank you. Well, it's great to talk to you about it.
Yeah, and thanks so much for joining us. I'm really glad we got to share this just personally and for the viewers back home.
Right on. Okay, great conversation and see you again soon.
Yeah, thank you so much, Alex.